Hello everyone. Let us see what is Floyd Warshall algorithm. Consider two locations A and B. Say we need to travel from A to B. Now, if there are a number of intermediate locations to be passed through while traveling from A to B, then the optimal choice would be to take the shortest path, and thereby we can save our time in traveling. So, how exactly do we find the shortest path? That is where Floyd Warshall's algorithm comes into play. The Floyd Warshall algorithm is used to find the shortest path between every pair of vertices in an edge weighted directed graph. It is advantageous in the way by providing the shortest path between every two vertices in a graph. It calculates the shortest path in the order of n power 3 time, where n is the total number of vertices in the graph. Now, by correlating this with the previously considered example, we can say that each vertex would correspond to each of the locations, and the edges that connect each of these vertices would correspond to the path between the respective locations. And for an edge weighted graph, the edge weight would correspond to the distances between the respective locations. This algorithm is said to follow a dynamic approach in finding the shortest path. Now, let us see how the Floyd Warshall algorithm is applied. We do this by solving an example. So, consider this problem here. So, we have this directed graph where the edges are all given some weights. So, it is an edge weighted directed graph. Okay. So, now if you see, we have an edge going from 1 to 2, 2 to 3, 1 to 4, 4 to 3, 4 to 2 and 3 to 1, and the corresponding weights in the edges are given. Now, the Floyd Warshall algorithm is initiated by starting with an initial distance matrix. Okay, so it is an n cross n matrix where n is the total number of vertices in the graph. Now, in this example, there are 4 vertices, so therefore we have a 4 cross 4 matrix. So the row headers and the column headers are the total vertices that is given. So we have 1, 2, 3, 4 and 1, 2, 3, 4 along the rows and the columns. Now the initial distance matrix is given by D0, where the diagonal entries are all given 0 because we don't have any self loops or multiple edges in the given graph. If there are self loop or multiple edges, then we remove those edges from the graph by retaining only the edge with the least weight. Now, this example does not involve any self loops or multiple edges. So therefore, the diagonal entries, since there are no self loop, the diagonal entries are all 0 for the distance matrix. So we give the diagonal entries as 0 like this. Now, the remaining entries in the matrix will be the weights of the edges. So if there is an edge that is directed edge that is going from 1 to 2, and then we write the corresponding weight. So for example, in this graph, if we see, there is an edge going from 1 to 2 and the weight is 8. So we write here 8. Similarly, 1 to 3, if we see, there is no edge. So therefore, if there is no directed edge between any two vertices, then we give the distance as infinity. So in this case, there is no edge between 1 and 3, so we give infinity. Now 1 and 4, there is an edge and the weight is 1, so we enter here 1. Similarly, for 2, we see that 2 to 1, there is no edge, so therefore we give infinity. 2 to 3, if we see, there is an edge and the weight is 1, so we give 1. 2 to 4, there is no edge, so infinity. Similarly, 3 to 1, there is an edge, we see this edge, so therefore the corresponding weight is 4. 3 to 2, there is no edge, so therefore we give infinity. And 3 to 4, there is no edge, so again infinity. 4 to 1, similarly, we have no edge, so infinity. 4 to 2, there is this edge, so we give the weight 2. Then 4 to 3, we have an edge with weight 9. So this is our initial distance matrix D0, where we have entered the diagonal entries as 0 since there are no self loops. So no self loops means the matrix entry is 0. Then if there is a directed edge that is going between any two vertices, then we enter the corresponding edge weight as the entry in the matrix, and if there is no edge, then we give infinity as the distance in the matrix. Now, the Floyd Warshall algorithm is applied by considering, in the Floyd Warshall algorithm, since we are finding the distance between every pair of vertices, so we will begin by looking into each vertices and we'll construct 4 different matrices: D1, D2, D3 and D4, where in each case D1, say for example D1, in D1 matrix the vertex 1 will be the intermediate vertex. So what do I mean when I say an intermediate vertex? So it means that we are looking for paths between every pair of vertices first, and then we are looking for path between the same pair via the vertex 1. Similarly, if I say D2, that means vertex 2 is my intermediate vertex, which means the same again. That is, we are looking for distance between every vertex, every pair of vertices, and also we will be looking distance through the vertex 2 between every pair. Similarly, we will get D3 and D4, wherein vertex 3 and vertex 4 are the intermediate vertices. Okay, so intermediate vertex means we are looking for paths between the pair of vertices via the intermediate vertex. So let us see. First, intermediate vertex is 1. So intermediate vertex is 1 means we retain. So in this case, what happens is we retain the entries corresponding to row 1 and the column 1 from D0, that is the previous matrix. So how we obtain the D1 matrix? By retaining the entries of row 1, that is this row 1, and the column 1 of the D0 matrix. So therefore, when I write D1, I retain row 1 and column 1. So that will be like this. So 0. Okay, so let me just erase this. Yeah. Okay. So I retain row 1 and column 1. So 0, 8, infinity, 1. And here column 1 is infinity, 4, infinity. So this is how I retain this matrix. Now since we know that the diagonal entries are all 0 because we have no self loops. So we enter the diagonal entries as 0. Okay. Now for the remaining entries in the matrix, we look at the D0 matrix. Okay. So first we need is we need this entry 2, 3. So D0 of 2, 3. What is D0 of 2, 3? From this D0 matrix, for the second row and third column, the entry is 1. So we write here 1. Now look at D0 of 2. Now we need to look through the intermediate vertices. So the intermediate vertex in this case is 1. So we go through 1. So D0 of 2, 1 plus D0 of 1, 3. So that entry is given by D0 of 2, 1 is second row, first column, which is infinity, plus D0, 1, 3 is first row, third column, again infinity. So if we see that we got 1 for the direct path from 2 to 3, and we got infinity for the infinity for passing through the vertex 1. So we see 1 is less than infinity, so we enter here, the entry here will be 1. Okay. Similarly, d0 of 2, 4 is equal to d0 of 2, 4 is second row, fourth column, which is infinity, and d0 of 2, 1 plus 1, 4. This is to check for through the intermediate vertex. So d0 of 2, 1 comma plus d0 of 1 comma 4. Now d0 of 2, 1, we know it is infinity, plus d0 of 1 comma 4 is 1, which is again nothing but infinity. So in this case we see that the value is equal. There is no lesser value in this case, so we enter infinity as it is. Now this means that there is no path from 2 to 4 via the vertex 1 or a direct edge. So therefore it is infinity. Now similarly, let us look at how the next entry is done. So we need d0 of 3 comma 2. So if you look at the d0 matrix, d0 of 3 comma 2 is 4. Sorry, d0 of 3 comma 2 is infinity. So we write infinity. Now similarly, we need through the vertex 1. So that is given by d0 of 3 comma 1 plus d0 of 1 comma 2. Now that is equal to d0 of 3 comma 1 is 4. So 4 plus d0 of 1 comma 2 is 8. So 8. So that is equal to 12. Clearly 12 is less than this infinity here, and therefore we give here 12 as the entry. Similarly, d0 of 3 comma 4 is equal to, what is d0 of 3 comma 4? We see it is infinity. So we write infinity. Now d0 of 3 comma 1 plus d0 of 1 comma 4. That is through the vertex 1. d0 of 3 comma 1 is 4. So 4 plus d0 of 1 comma 4 is 1, and that is given as 1 here. So we get 5. Clearly this is less, so we enter 5 here. Similarly, if we see d0 of 4 comma 2 is equal to, d0 of 4 comma 2 is equal to 2. So 2, and d0 of 4 comma 1 plus d0 of 1 comma 2, that is equal to 4 comma 1 is infinity and 1 comma 2 is 8. So that is again equal to infinity. Clearly this is lesser, so we give 2. Lastly, d0 of 4 comma 3 is equal to 9, and d0 of 4 comma 1 plus d0 of 1 comma 3, that is equal to 4 comma 1 is infinity and 1 comma 3 is also infinity, so we get infinity. Clearly 9 is lesser, so we enter 9. So therefore we see that this is the D1 matrix. So now we got the D1 matrix. Now to obtain the D2 matrix, we need the intermediate vertex as 2. Similar to D1, where the intermediate vertex was 1, we retain column 1 and row 1 entries as it was in the D0 matrix. Similarly, for the D2 matrix also, we will be retaining the column 2 and the row 2 entries as it is in the D1 matrix. So if you see in the D1 matrix, the column 2 is 8, 0, 12 and 2. Here also similarly, we are retaining it as it is in D2 as 8, 0, 12, 2. For row 2, we see infinity, 0, 1, infinity. So we have retained here also infinity, 0, 1, infinity. Now, since there are no self loops in our diagram or in our graph, we have entered the diagonal entries are all as 0. So therefore, the diagonal entries are 0 in my D2 matrix as well. Now, for the remaining entries, we do the same process as we did for D1. So first, we are looking to D1. We are looking into D1 of 1, 3. D1 of 1, 3 is infinity, and D1 now through the vertex 2 we have to check. So that is D1 of 1, 2 plus D1 of 2, 3. So D1 of 1, 2 is 8 and D1 of 2, 3 is 1. So 8 plus 1 is 9. So clearly 9 is less than infinity. So our entry here will be 9. Now in the next case we have D1 of 1, 4 is equal to 1 and D1 of now through vertex 2 it is D1 of 1, 2 plus D1 of 2, 4. So that is 8 plus D1 of 2, 4 is infinity. So 8 plus infinity gives me infinity. Clearly 1 is less than infinity. So my entry here is infinity. Again for the next one we need 3, 1. So D1 of 3, 1 is 4 and D1 of 3, 2 is 12 plus D1 of 2, 1 is infinity. So 12 plus infinity is infinity. Clearly 4 is less than infinity, so we enter 4. Similarly, we do for all other entries as well, and I get the answer to be, in this case, D1 of 3, 4 is 5 and D1 of 3, 2 plus D1 of 2, 4 is again 12 plus infinity, infinity, 5 is lesser, so I enter 5. For D1 of 4, 1, it is infinity and D1 of 4, 2 plus D1 of 2, 1 is also infinity, so they are equal, so we retain infinity as it is here. D1 of 4, 3 is 9 and D1 of 4, 2 plus D1 of 2, 3 is equal to 3. So clearly 3 is less than 9, so we enter 3. So finally we have this as the D2 matrix that we have obtained from D1. Following the same procedure, we can obtain the matrix D3 and D4 where the intermediate vertex is 3 and 4 respectively. And these are the matrix entries that we have obtained by following the same procedure that we did for D1 and D2. So now, these 4 matrices gives me the information regarding the shortest path between every pair of vertices through any of the vertex that we want. And therefore, this is how the Floyd Warshall algorithm is applied to an example, and we can obtain the matrices wherein we have the required info to identify the shortest path between every pair of vertices.